Okay, so here's the setup for the cyclohexanol to cyclohexene reaction. In the sand bath, we have our 25 milliliter round bottom flask, and in there we have the cyclohexanol that we gave you and the catalytic phosphoric acid. And attached to that we have the column with the copper wire placed in it to help with the fractional distillation. And then again we have the three-way adapter with the thermometer adapter and the thermometer, and you want the top of the thermometer head to be in line with the side arm of the condenser. So we have our condenser attached, as well as this other adapter and a 50 milliliter round bottom flask in an ice bath. Before you put the round bottom flask in the ice bath, make sure that you have a drying tube attached to the adapter as well. And so we are going to let the reaction start to progress. We want to make sure that the sand bath is on to at least 8, and we want to make sure that the round bottom flask is really buried in the sand bath. So you can use your spatula, scopula, to really bury it. If needed, we can put some glass wool and tin foil around it to help really insulate the reaction so that it proceeds efficiently. In addition, remember that we have the boiling chips to prevent any bumping. Okay, so we set up the distillation and it's been running for a while. We put aluminum foil to help insulate it so that the reaction progresses in a timely manner. And so the boiling range, remember it's not a boiling point, you're going to record a range, is when you see the first drop, and then you'll notice that the thermometer will go up a couple degrees or so, and it will stay at that range while it's boiling. And you will keep having it react until there is about 3 or so milliliters in your reaction flask. You will have to remove the aluminum foil to see that. Or you will notice that the thermometer either shoots up to a higher degree a lot, or the temperature will start to decrease. Okay, so we know that the reaction is done when there's only a small amount left in the reaction flask. It might change color slightly, and then the thermometer temperature has gone down, and as you can see here in our ice bath, which has melted slightly, it's kind of a cloudy mixture, and that's our cyclohexene product with a little bit of water. Okay, so now that we have our cyclohexene in the round bottom, we are going to use either a dropper or a glass pipette to get rid of the water that's on the bottom. If you can see, there's 2 layers, and so we can just use a pipette. Make sure to try and get just the water and not the cyclohexene product. You can put that into just a labeled beaker so you know that it's the excess water, and there's still a little bit in there, so I'm going to grab that up. And if you can see in the pipette that some of the cyclohexene is in the pipette itself, so when we transfer it, we're going to try and get all the water out but leave the cyclohexene. And there we go. And then now we have our cyclohexene, and we can transfer this to an Erlenmeyer where we can add the sodium sulfate to dry it. Okay, so now that we have dried it with the sodium sulfate, and decanted. We put it in a round bottom flask with a boiling chip, and we set up a simple distillation. So you notice we don't have the column with the copper gauze. And for our receiving flask, we're actually going to use a test tube that should be weighed previously. And when you collect the cyclohexene, you can go ahead and weigh the test tube with your cork. And so you will have your yield right at the end of lab.
Okay, so we have our two test tubes. We have our negative control for the bromine test, and then our bromine test of the cyclohexane, which should turn out positive. And so we just have about 1 milliliter of solution of the bromine in chloroform. So for our negative control, we're just going to pipette a couple of drops of chloroform, which is the solvent. So that should be a negative test. And then kind of swirl it around. It's still colored, so that's a negative test. And then I'm gonna switch the pasture pipette so we don't have any contamination. And then here's some of the cyclohexene and the graduated cylinder. I'm just gonna pipette a couple of drops in here. And then you can see that it turns clear. So the disappearance of the bromine color indicates a positive test. So we have no more bromine and it's all reacted with the cyclohexane.
Go.
Okay, so for the Bayer test, you just want to make sure that you have a negative control and a positive control. Both of them have 1 milliliter of ethanol. So to start off, I'm just going to add 2 drops of the Bayer reagent. And you'll see that right now it's purple. So now I'm going to add a couple drops of my negative control, which I'm using ethanol. And you'll notice that the mixture remains purple. So then I'm going to add 2 drops to my positive control. And the mixture will be purple. And then I'm going to add 2 drops of my cyclohexene. And you'll notice that this one will turn a brown color because it's producing manganese oxide, which is a brown precipitate.